get in their panel positions. It's just so great to be here today in DC at the Common Grain Alliance meeting. My name is Erin Silva. I am a professor at the University of Wisconsin-Madison. In my position, I do work in organic and sustainable cropping systems. So my position is actually an extension position. I do a lot of research related to diversified grain rotations in the upper Midwest, but I also work quite a bit with farmers throughout the Midwest in my extension capacity. In that, we do a lot of programming, conferences, workshops, field days, resource development, and we do it a lot in the context of partnerships. So one of our primary partners within my program is the Artisan Grain Collaborative, which I think is a sister organization to the sponsors of this event today. So the Artisan Grain Collaborative and their executive director, Alyssa Hartman, really has some of the same vision and goals and motivations of seeing more local and regional grain production in the Midwest and really building those regional grain sheds in collaboration with farmers and bakers and distillers and maltsters, and really bringing together a community to move us forward. So with the Artisan Grain Collaborative, we host a winter conference. My extension program is called OGRAIN, which is the Organic Grain Resources Information Network. And so we hold a winter conference first weekend of February. If you guys want to check it out, it's worth the drive to Madison, Wisconsin, even in the winter. Madison's an awesome town with a great local food culture. So it's 2 days of all things organic grain. So we have a feed grade track, but we also have a food grade track where I think there you'll see a lot of people whose names we've mentioned today. Tor Oshner's coming to speak, Klaus Martins, some farmers from New York. So we have a great lineup of food grade grain producers and looking at everything from production to harvest to marketing. So it's, if you Google UW OGRAIN, you'll find that. The other thing we have going on with Artisan Grain Collab, which I think is really cool, is a program called Midwest Grit. And that's been funded by a USDA Beginning Farmer Rancher Development Program. And that GRIT stands for Grain Resource Immersive Training. So what we're looking to do there is to build more capacity, particularly within beginning farmers, and more opportunity for getting into specialty grains, feeding into local and regional markets. So and the exciting thing about that too, which is really cool, it's also in collaboration with Michael Field's Ag Institute, is it's focused on underserved farmers. So there's an emphasis on women farmers and farmers of color. And we were a little nervous and skeptical that we'd be able to get enough participants that fit those categories, but we've actually exceeded our goals. So it's just so cool to see the diversity of people that are interested in forwarding this movement, get into local and regional grains, and really bring this whole new way of thinking, not new way, old way of thinking, but going against the conventional paradigm forward. So it's a little bit of context about me. One other thing, I'm also the director of the Center for Integrated Ag Systems, which is really looking at, again, transforming our food system, bringing our food system back into a way that connects people with the land and building local and regional economies. So as part of that, I have a scientist that works specifically in local grain production. So she just finished up 2 reports. One is the drivers and deterrence of small grain production or adoption in the upper Midwest. And then also a shorter fact sheet. So I brought some copies if anyone wants to grab those. And one of the motivations for doing publications like this is to help drive policy change. So if we can understand what are the barriers, hopefully we can put policy in place that will help farmers overcome those barriers and stimulate also economic development. So feel free to grab a copy. So with that introduction of myself, I'm so thrilled to be here to give a small primer, short primer on soil health, and then talk with our excellent panelists about how that translates to what they're doing on their farm and what they're seeing. And particularly in the area of soil health, one thing that I really find exciting about working in the area of soil health as a scientist is that I see it really as a movement that involves farmers and the generation of farmer knowledge as well as traditional ecological knowledge, and pairing that with what we can do at the university with our capacity with doing research trials and being able to collect data, really moving forward with our understanding together. I mean, quite honestly, as someone that's worked at a land-grant university for over 20 years, not to overly criticize or say that people were trying to move us in the wrong direction, but with all of our agriculture, I definitely recognize that the role that land grants have played in terms of moving us in the direction that we can't be further moving into, but particularly with respect to soil management. Throughout the 1960s and 70s, with the advent of industrial agriculture and synthetic chemicals, the whole way that our science was done and our understanding of soil management was really going towards that input-intensive, chemical-intensive system. We'll talk a little bit about that. But I think, over the past decade or so, we've increasingly recognized, and certainly there's been people both within and outside of the university system, including Elaine Ingham and the work being done at the Rodale Institute, that recognize this long before I think the universities really started to investigate this more fully. So again, certainly there's been really groundbreaking leaders that have recognized the importance of soil biology and then how that translates into soil health. But it's something that I think as we continue to move forward in terms of how do we improve our soil health and how do we find practical ways that farmers can forward the soil health on their farms, it really is something that, again, is very collaborative as much of the work that we do. So the premise of the panel today is cereal grains, especially those grown with organic production practices, I would argue, but not necessarily constricted to organic production practices, are key to improving soil health and increasing resilience. And I think the increasing resilience part is critical as well. I know in the Midwest, we experienced a pretty severe drought. I know in the Northeast, there were some drought conditions early on that broke, and actually there's now excessive rain. But I think we all recognize that as a global society, especially over the past year with the wildfires in Canada and the crazy weather, we're going to really have to focus on how do we create these resilient systems. Soil health is key to resilient systems, and again, I would argue that growing cereal grains and developing these local and regional food economies are going to be absolutely essential when we talk about resilience and food security. So this goes back to what I was talking about in terms of, I think, the land-grant university's lack of recognition of soil as a complex ecosystem. I think both within the scientific community and within the industrial conventional farming community, soil was taken for granted. We certainly, as a country, saw the risks with respect to not soiling stewarding our soil resources. We saw the Dust Bowl in the early 20th century, saw the results and the impacts of not managing our land appropriately, but we really didn't take that lesson seriously. I mean, there were initiatives that were forwarded, such as the creation of NRCS and other policy that really on a very surface level tried to address some of those risks and issues. But like I mentioned, even with our science and the way industrial agriculture viewed soil, it was really seen, I think, more as a medium that was not recognized in terms of its complexity and its broader resource. It was looked at something that held roots in place, and we needed to apply chemicals instead of recognizing it as an ecosystem that, if managed correctly, was really functioning and cycling and was able to support a great degree of productivity. So we've, I think, historically taken advantage of our soils and taken them as a sustained resource not seriously enough. So what is soil? If we look at it in a more complex way, soil it's a very dynamic, heterogeneous system. And this is something that absolutely amazes me about soils when we think about what they do and how they function, the complexity of those interactions. It's not just a physical medium, it is a world in and of itself in terms of the soil biology and how the structure and the conditions of the soil feed the soil biology, and increasingly how we're learning about, and again, I think it's not to, I definitely want to recognize the importance of traditional ecological knowledge and how indigenous cultures, I think, have recognized this for centuries, if not eons, that there's a communication between the plants and the biology, all these feedback mechanisms that we've increasingly, I think, detached and lost, even with our plant breeding. But we now know that the plants can communicate with the microbes through what they're exuding through their roots. They can actually alter, and plants aren't passive in their ecosystem, they can alter the soil microbial environment. And they feed the microbes, and the microbes then feed the plants. So it's a very dynamic system, and how we're managing it, no doubt, can alter that system. So it's not only the soil particles, but what also impacts these soil biological communities is the water and air. And when we think about how we're managing our soils for soil health, we have to think about that water and air component. I like to think of, like, as we're managing our soils, think about how we're also, you know, helping support our families. And what do we do for our families to take care of them? We provide the best food possible, best nutrition possible. We give them a house and a place to stay. And I think when we think about our soil biology on our farms and on our land, we need to think about taking care of our soil microbes the same way. They are a resource that we want to give good housing, and that's part of the soil structure, making sure that the air and the water flow through so that they have an environment where they can thrive and have a diverse, healthy, functioning soil community. There's not only the soil microbes, but there's a living and decomposing plants, which are absolutely critical. A big part of soil health is keeping those living roots in the soil. Like I mentioned, with the roots are pumping through to the microbes, they're feeding the microbes. And if we shut off a food source for months of the year, how is that helping our soil microbes? So it's the living plants in the soil, it's the other microorganisms in the soil, it's those cycling nutrient pools. Unfortunately, this all takes time. So as we lose our soils and don't structure or don't support these resources, it's going to take time to rebuild it. From a farmer perspective, I don't want that to be too scary in terms of this is a hopeless endeavor to try to improve our soils. There are some short-term management we can do, but also recognition that this is going to take some time to see some of these changes as we try to improve the soil health on our farms. And like I said, they're really a foundation for resilient systems. So these systems are going to help us as we face challenges with respect to climate change. They're going to help us reduce the inputs on our farms, and they're going to create more stability in production over the course of years. So some of the definitions of soil health that are out there, the ability of soil to support crop growth, capacity of the soil to function in a productive and sustained manner, capability of the soil to produce safe and nutritious crop, or fitness for use. These are older definitions. I still feel like these are still a little extractive and narrow in terms of how we're viewing the soil, and soil health in terms of what can we gain in terms of more production. And I really am hesitant to think of what we want in terms of soil health is continuing to intensify our production and increase crop yields. But instead, I think we can think of soil health as a measure of function. So what are we hoping that the soil, what do we want the function? So we want the soil to function more than just crop yield. Certainly we need to have a certain level of production to feed our communities, but we also want nutritious crops. We want nutrient-dense crops. We want other ecosystem services such as water infiltration, having clean water within our communities. Being able to support other aspects of biodiversity. So whereas those older definitions I think were more narrow, I think we need to think of soil health more broadly. Overall, that function can be defined as the optimum status of soil's biological, physical, and chemical functions, and that they sustain plant and animal productivity, but again, the biodiversity, enhancing water and air quality, supporting human health by giving us nutrient-dense, chemical-free foods and wildlife habitat. So they're not just, the soil is not just a medium to grow plants, but it's a living, dynamic, and changing environment that is influenced by what we do as farmers, as a broader community, by what we purchase, by the ingredients we use, and what we support in our policy. So these are the 5 soil health principles by NRCS. Sometimes I'm a little skeptical of NRCS and federal programs, but I do think that these are pretty sound principles. That as we're looking at how do we put these practices on our farms, and particularly how do cereal grains play such a key role. The first principle is soil armor, keeping that soil covered. I think the living component is key to this. The more that we can have green on our soil, the better. The more that we can have diverse green, even better. But soil armor, also having residue, so keeping the stubble after harvesting, keeping that residue on the soil, that's also armor. Minimizing soil disturbance. So I work in organic. We still have tillage and cultivation in organic. Soil disturbance is a key part of weed management. I would argue I don't think we need to have no-till systems. I think we need to do our tillage in a smart way. I think we always need to be returning something back to the soil. I think we need to think about the equipment we're using and how we're using the equipment and the conditions we're using it in. But I think that I know that there's a lot of long-term research trials that are out there that have shown that even with some degree of tillage and organic management practices, that we can still see gains in our soil health and soil carbon. So I don't want to be so dogmatic that we need to go no-till, which I think has been pushed by the conventional industrial ag industry in favor of selling chemicals. So the conventional no-till paradigm of using Roundup, I think, you have even worse outcomes than having some degree of tillage. So the minimal, I think, is key there. Plant diversity. The more diversity we can have across time in our crop rotations, cereal grains are wonderful for increasing crop diversity, not only by getting us beyond corn and beans, at least in the Midwest, where we see as kind of our overarching crop rotation, but also opportunities for cover crops in. Continued and living plant roots, I mentioned this, and livestock integration as well. So this is a little tricky as we look at grain production, but the more we can think about how we integrate livestock and how do we bring poultry or grazing heifers or adding beef operations on the farm, that's also going to help us improve our soil health. So I know working with farmers, being part of Extension, one of the biggest questions I get is how do I know that I'm improving the soil health of my farm? So what sort of tests can I do? And we look at different soil health indicators. They can be put into 3 categories: physical, chemical, and biological. The physical and chemical are pretty easy with respect to standard soil tests, although I think there's still a lot of question in terms of, do our standard soil tests tell us enough in terms of micronutrients or other ways of looking at the soil chemical properties in terms of creating a balanced soil. But those are pretty easy to get off a standard soil test. Physical properties, like bulk density, penetration resistance, how much compaction you have, aggregate stability, those are a little harder to capture, but I think there's some of that you can see physically as a farmer, knowing your soils. You can see the aggregation, that beautiful cottage cheese structure. You can get a penetrometer, see if you have a compaction layer. The trickier part, again, maybe this is also part of the lack of science, is that biological component. How do we measure that biological component? How do we know that we're improving our soil biology? What are we trying to improve it to? I think there's a lot of unanswered questions, and I'm always nervous when farmers spend a lot of money on soil biology tests because, I mean, quite honestly, I'm not sure what they can tell you in terms of management. I don't think that we know exactly what we're looking for or the best ways to test or the best times to test. I think that potentially getting some annual soil biology tests, whether it be in the form of a Haney test or a phospholipid fatty acid test, could be valuable. I would recommend taking them at the same time and trying to standardize how and when you're taking them. But I just also want to recognize that there's still a lot of unknowns there, and I get really nervous when a company's trying to sell a farmer a test and recommendations based off of that test, that they're really sound recommendations that are based in a scientific rigor that would be helpful to farmers. That is not at all discounting the importance of soil biology. It's absolutely critical, but I just don't feel like we're there yet in terms of testing. This is way too small, and I'm not even sure if I can read it. Let's see what I was trying to say here. So this is looking at particulate organic matter. Particulate organic matter in general. So one of the aspects that I do think is something easy for farmers to measure that is a key aspect of soil health is organic matter. We've known for years within organic the role of humus and organic matter as a key element of what we're trying to do as we're stewarding our land with organic practices. And I think as we've looked at these soil health indicators, one that has held up is organic matter. So I think generally, if you're looking for an indicator, if you're seeing organic matter gains, you can be confident that you're seeing gains. I think what I was in part looking at, this is a long-term cropping systems trial at University of Wisconsin-Madison, looking at organic matter gains at different rotations. And overall, what I wanted to point out with this is that we do see gains with diversifying rotations and adding perennials in the soil. But just also organic matter, I think, is one of the key elements we're looking at. The other key element that I think is pretty easy, relatively easy to be able to assess in a more visual way is soil aggregation. So soil aggregation, as we're talking about building that home for our microbes and creating an environment where the biology can thrive, soil aggregation is both a function of having good soil biology as well as being able to foster continued improvements in soil biology. So it's the way that those soil particles are held together. And the soil biology, particularly the fungal communities, they create these gums that help stick the particles together. And that creates more of these aeration through the soil, so water and air can move through the soil. It also sticks the soil together so it's less prone to water erosion. And as we're seeing more increased rain events and heavy rains, that certainly is key. And again, not only does it help foster our soil biology, but it's created by our soil biology. So putting in those carbon inputs, those living roots in the soil, cereal grains are great for adding root biomass and organic matter to the soil. But it's also, there's elements of aggregation that you're kind of stuck with by the soil type on your farm. So your soil texture, rotation, trying to put in more phases where you have, again, returning carbon back to the soil. And this is where the smart tillage comes into play as well, because over-tilling or doing tillage at the wrong time can certainly negatively impact your aggregate stability, but doing it right. I don't know if any of you have heard of Gary Zimmer. Gary Zimmer is a colleague of mine in Wisconsin. He started Midwest Bioag. And one of his concepts as an organic farmer is he's always returning, every time he tills, he's tilling in a cover crop. So he's always tilling in green material. He thinks of it as like paying his dues. You're paying your dues with tillage by returning something back into the soil. And he thinks of it as like he would feeding his cows, that he's trying to feed like a heavily nutritious cover crop back into the soil. So I mentioned why we want this soil aggregation. It helps prevent erosion by wind and water. It also helps with the drought tolerance of the soils as well. It's something that we want to improve our resilience of systems. We want to be able to have that soil be able to soak up those heavy rains, but we also want to keep that water in place in drought times. And soil aggregation and building of organic matter helps do this. I love this photograph. I hope you guys can see it with the lighting, but this is something that it's called a slake test. So it's taking, and it's amazingly, and you could probably do this on your own soils and your farm, where you take a clump of soil and you put it in a cylinder of water and you see how that disaggregates. And you can see the difference between no-till and conventional tillage, conventional tillage with vegetable crops, and then permanent cover. That the permanent cover, which is kind of the gold standard for soil health and aggregation, that when the clump is put into the water, it's held together. And those are because of the glues of the soil biology, because of the good aggregation and structure, versus the conventional tillage, where you see that that soil just falls apart. And you can imagine in a heavy rain, that soil just falling apart, breaking apart, going into the river systems, contaminating our water, and that soil being lost from our farmlands. So that aggregation is what's gluing it together, holding it in place, and creating that resilience.
Is it floating as well? It's kind of hard to tell from that.
It's foaming for some reason. I'm not sure why it seems to be foaming and floating. What's about the chemistry of it? But the permanent, yeah, it is, and that the clod is, and that may be because the air within it is creating some buoyancy. So that air component is critical. And yes, the movement of water in the air through these macropores. Have any of you seen this demonstration by NRCS? This is a great one too. I love this one because it's just, I think this should be like shown to all policymakers in terms of just the visual of this, where these are like sections of soil that were cut out from differently managed ag lands. So there's permanent pasture and management intensive grazing and conventional tillage. And then there's a sprinkler on the top that puts on, a fairly heavy, not crazy heavy, but a decent amount of rain. And then you can see from the front jars what water is being run off the field and the amount of soil that's being run off the field. And then the back jars are what's infiltrating through the soil. So you can actually collect like what is actually going off of our fields into our waterways, not going down into the ag field where our plant roots need it. You can see on the far, the bare patch right here, that so much of that water is moving off the field, like it just would in an ag field, go into the ditches, and how much soil is being run off with that. And that's a function of that soil armor, and that's a function of the soil aggregation. So just these visual demonstrations that what we're doing to our land is definitely affecting our ability to maintain our soils. Soil compaction is another big one with respect to soil health that impacts water movement and water holding capacity, root growth and proliferation, and soil aeration. And again, tying it back to cereal grains, having those roots in the soil is so important for mitigating soil compaction. So putting cereal grains in our rotation, having those great fibrous root systems, having the opportunity to put cover crops in the system like tillage radish, sunflowers that have taproots in the system. So having those cereal grains in our rotation can help us use our plants and our soil biology to help mitigate compaction. And this is what we want to see, these beautiful diverse root systems that go deep into the soil, do biotillage, help mitigate that plow layer, and using the ecology and soil biology to build soil health. And this creates so much resilience. As we look at lowering our input, the more root growth we get, the more the plants are able to access nutrients and water. So roots in a loose, how much root growth gets put on, if we have those compacted soils, lack of aggregation, lack of soil structure, lack of root growth, which means more inputs, which means less access to water. So wrapping up, looking at the biological aspects of soil health, soil microbial activity, so the microbes we can't see, but so critical in terms of cycling nutrients, so critical potentially with even respect to bringing nitrogen in the system. Not only the nitrogen fixing bacteria like rhizobium bacteria that are in synergy with plant roots, but also free living nitrogen fixing bacteria as well. Flora and fauna, the micro aspect of soil biology, the earthworms, the beetles, the other decomposers that have essential function in the system. Soil nutrient mineralization. This is a lot of the interest, I think, from the conventional side in regenerative agriculture is because we're looking at the farmers are interested in lowering the inputs. And it's through this cycling of nutrients, just like we would in a natural ecosystem, that we're able to make nutrients available to plants. I think we see this particularly with phosphorus. I mentioned, again, how I think the conventional paradigm of our soil science departments have sometimes led us, maybe oftentimes led us in the wrong direction. One, I think, aspect of that is our soil tests and how much nutrients to apply. And I think phosphorus is one of them that it's obviously soil tests. You have to know what sort of phosphorus test to get. But I think we're learning more and more in organic systems that what that soil health or what that soil test tells us in terms of our fertility recommendations might not be reflective of what organic farmers see, because that soil biology is releasing a lot more nutrients that might be anticipated than off of a soil test. So there's a lot I think that we can think about in terms of soil function and lowering inputs and creating environments where nutrients are available to plants. And then nutrients being available to plants, we can then make the connection of nutrient-dense food from there. Having a healthy soil community, though, also can help decrease soil-borne pathogens. So when we look at some of the pathogens we struggle with in our systems that are living in the soil, just like when we think about our own gut microbiome and trying to create a microbiome that helps with our own immunity, it's the same in the plant ecosystem as well, that having a diverse microbial community can help lower soil-borne pathogens, and they can also help stimulate the plant immune system that helps them fight pathogens. So lots of cool stuff going on. And there are the ecosystem is so diverse, so complex. In a teaspoon of soil, there are billions of bacteria, fungi, protozoa, nematodes, good and bad nematodes, arthropods, and earthworms. Of all different sizes. And these are involved in nearly every aspect of soil quality. So I mentioned how they create the gums that help with soil aggregation, access to nutrients, decomposition, and that cycling of residues. Sometimes you go past a conventional cornfield and like 18 months later, you still see those residues on the soil, which to me is indicative of a dead system. Those residues should be cycled through the system in an effective way. Stabilization of soil carbon. We're learning more as we look at climate smart systems that a lot of the stable carbon is actually held in soil microbes' bodies. It's not in soil organic matter per se, which is cycled, but that more stable carbon is actually held within the soil biology. So as we look at building soil biological systems as biological farmers, we're also looking at developing climate smart solutions in a more stable way. And I mentioned plant immune response as well. So there's signaling between the microbes and the plants, and having a healthy soil community can help plants be more resistant against insects and diseases. Arbuscular mycorrhizal fungi, this is something that a lot of farmers are interested in. These are one of those synergistic microorganisms that can benefit the plant by having improved water access and nutrient access, stronger pathogen response, greater resilience to abiotic stresses, and can ultimately increase a yield. So these are a particular type of fungi that interact with plant roots. So they actually have these associations within the root cells that they basically act as extensions of the root system. So we talked about with the kind of that desire for loose soil and that proliferation of the root system, this creates an extra proliferation of the root system, particularly with access to water and phosphorus. So by having these mycorrhizal associations, it again helps us reduce our input and create this resilience in drought situations. So this is just a little schematic to show like a root system and a typical cereal grain versus with this mycelium network, how much more robust that access to resources would be. And then we know about rhizobium bacteria as well, and the importance of legumes and cereal grains helping us create that rotation that put more legumes in the system. So these rhizobium bacteria, similar to arbuscular mycorrhizal fungi, can associate with plant roots. And whereas plants, we have 80% nitrogen in the air, in our composition of our air, when nitrogen is an essential nutrient for plants and plant growth, but plants can't directly access that nitrogen from the air. However, microbes can. And having the rhizobium bacteria in the legumes, not all plants, only the plants within the family of legumes can have these associations. So where those are the clovers and the alfalfa, and the peas, they form these associations, and the plants, the legumes, give the bacteria carbon, so plants are able to fix carbon, so they give them a sugar food source, and then the bacteria give back to the plant the nitrogen that they're able to take from the air and capture it and put it into a plant available form. So there's synergistic relationships that allow us to basically put more nitrogen back in the system that is not reliant on having manures or synthetic pesticides. So building these systems, and cereal grains are a core part of that, where we can intensify our legume production, is going to help us solve some of the issues with nitrogen, which from a conventional standpoint is one of the most energy intensive, carbon intensive parts of the energy balance of agriculture. Synthetic fertilizers, particularly nitrogen, are a huge impact on carbon footprint. These are what the nodules look like, and there's actually heme within them. So if you split them open and see them pinkish, that means you have a functioning legume. And this is my last slide, and this is second to last slide. This is a study we did off of that long-term cropping systems trial, and basically what we saw, and just a schematic I won't go through, but is that indeed the circles are clustered around different treatments, anything from conventional continuous corn to organic grain that has a cereal grain, to alfalfa, to a corn, oat, and alfalfa rotation, organic versus pasture. And these different circles represent different clusters of microbiological communities that are similar. And basically what it's showing us is, again, yes, indeed, as we do different practices, we differentiate those soil biological communities. So again, I'm not confident right now we have a test for farmers to be able to show, are you moving in the right direction of the soil microbial community that you want? But just to be confident that yes, the practices that we do impose are making a difference, and we are able to change these soil microbiological communities. And just some best management practices: minimize compaction. So going over the field at the right time, making sure your equipment is the appropriate equipment in terms of size and scale and tire pressure, optimizing water flow and air exchange, providing continuous energy by keeping living roots in the soil. Cereal grains are wonderful for this, by both having the winter cereal grains as well as opportunities for cover cropping. Reducing tillage, not necessarily eliminating tillage, but reducing tillage, particularly as we're favoring our fungal-based food webs. Providing diverse food sources in terms of diverse rotations and cover crops, and then rotating crops to reduce pests and microorganisms. So now I get the pleasure of introducing, and we can talk with our wonderful panelists here about how they view soil health on their farms and what they're doing and how cereal grains have played a role in that. So I am going to let them introduce themselves and start with Teena Bailey.
Can you hear me? Okay, all right, yes. I'm from Pennsylvania. I guess a lot of you folks are, I would almost call you Southerners, but I'm a Northerner. Where I live is northwest of Allentown. That's Billy Joel's Allentown, Bethlehem. It's just south of the Blue Mountain Range, which goes from Virginia up to New York. I farm a small acreage. Our home farm is only an acre and a half, so I rent land. I rent about 8.5 acres of land about 3 miles away from our farm. I grow wheat, oats, and rye. I tried to grow barley, and I have been somewhat unsuccessful. Bridget Gilmore has a few bags of a type of heirloom barley. It's a Tibetan purple, and I've tried to grow that in our soils, and it lodged badly. I gave some to Rodale Institute. Bridget works with Rodale or for Rodale. They had the same problem. So I was not successful with that because everything just fell over. She has some bags of it. If anybody would like to try it in your soil, we don't know exactly what it would prefer to stand upright all year and be able to be harvested. I have more if this is gone today.
Need boron and silicon.
Well, maybe so, or maybe it needs, a stronger stem. Does it need?
That's what makes the stronger stem, the silicon.
Yeah. Well, my other grains do very well in those particular fields, but this was just different, and the same thing happened at Rodale. So, is it another factor besides that, like the climate? Does it need really poor soil? Does it need cooler growing conditions? This is what we're trying to find out. So that was kind of a rabbit trail, but most of my sales of grain are to small retail operations, home bakers, and through farmers markets. The oats I roll into oatmeal, or rolled oats for my customers. That's something we haven't talked about too much today, I guess, but that is definitely a big seller for me. So I grow a hull-less oat, so I don't have that process of having to be hulling. So that's, in a nutshell, what I do. And I do all of it myself with smaller, old equipment that my dear husband had sourced for me on the internet over the years. So.
And David.
Thank you, Teena. And Erin, thank you for it's a lot of information. Such a fascinating subject. It's awesome to hear someone speak so passionately about soil and knowledgeably, more broadly about the industry. I feel like we're in good company as I feel like I'm a little bit of a soil nerd. To be with other people who are passionate about soil, this is important. And just as a quick read of the room, how many people in the room are farmers or producers who are otherwise working with soil in a production capacity? Okay, so we got a good number of you. And just as again a test, if it's okay, how many people were already familiar with mycorrhiza, the term mycorrhiza? Okay, so again, it's a fairly knowledgeable crowd, and that's really great to see. And in your introduction, some of the, all of the points that you raised, but some of the names in particular, as we share in sort of this sort of new understanding, there is, I think, a greater emphasis on the value of protecting this biology to create healthy living soil. But quick word about what we're doing. I am with my father here at Grapewood Farm. We are in Montrose, Virginia, which is on the northern neck, and we do organic grain. We have worked with Rodale to develop a 3-year rotation, somewhat as an experiment, leaning into really the strengths of our land, our equipment, the types of equipment we had available to us, which is not always the same for everyone. And I've developed an interesting study of the soil, just to see over time how it has either improved or changed, or where we've succeeded, or maybe where we've made some mistakes. And when it comes to soil, I mean, I think it's, especially with some of the machinery that we're using, there's such, it's incredible, it cuts both ways. You're able to get tremendous work accomplished, but how quickly we can destroy something so precious without an understanding of what we're doing. So as we are here today and discussing some of the practices, I mean, I look forward to really learning and have already learned from, I see Pete in the back, how many opportunities we have to learn from each other. And I think that's really important. So thank you.
Great. So now that we've heard about your farm operations, we're going to jump into the questions. So the first question is, you talked about some definitions of soil health, but as farmers, how do you define soil health on your farm?
Okay, and thank you, Erin. I will echo what David said about your presentation. I can tell you're passionate about it, and it's just wonderful to hear what you said. I learned some things, but you also reinforced, so thank you very much. Now, let's see, what was the question?
So how would you, as a farmer, how do you define soil health on your farm?
Okay, well, I guess I look at a number of things, both above the soil and beneath the soil, in the soil itself. I'm part of a PASA program called the Soil Benchmark Program. PASA is the Pennsylvania Association of Sustainable Agriculture. And I guess since 2019, I've been part of this program where I do test the soil every fall, and PASA pays for a soil profile to be put together from the test from Cornell. And Cornell does a number of the things, Erin, that you were talking about. Aggregate stability, water infiltration. They look at a lot more of the soil profile than just a university test. And that has been wonderful. It is expensive, I believe, to do it by yourself, but since the Soil Benchmark Program has been paying for it, it's very affordable for me. And it has helped kind of show me what's going on in the soil itself. I also look at my yields. I look at the quality of the grain, and I look at what weeds are out there. That's one thing that, I don't think I've heard the word weed yet today, but that's something that I really deal with. And
yes, you're right.
the weeds. I inherited some small plots of land from conventional farmers who didn't want to deal with them because they have like these huge combines and pieces of equipment that they could hardly turn around in the field. So I inherited weeds, especially Canadian thistle. And I'm dealing with that, and I'm trying to balance tillage and crop rotations with production and getting rid of these thistles or minimizing it. And I'm still struggling with that. So I look at the weeds, I look at the yield, I look at the color of the fields. What does it look like? Is it green? Is it yellow? And I look at the soil benchmark tests that I get every year.
Yeah, absolutely right. The lessons we can learn from observation, I think, is really important. Being in the fields, walking the fields, and the countless hours spent pulling weeds that you just happen to see. You can't walk past it. So, and certainly I'm glad to hear you talk about the testing. From a chemical analysis point of view, certainly we can look at that organic matter. And I think during your presentation, I laughed when I think you showed a slide on building organic matter. I mean, how it's very difficult to do. And really, even back to this morning, as we heard the excellent presentation from our panelists, but it is not absent from that discussion. I felt was the challenge involved with growing, which is not easy. But as we look at our soil and try to evaluate it with any sort of sense, or are we moving in the right direction? Are we helping build, improve it? I'm also interested in the developing of better methods for biological analysis, and whether that's through a lab or better tools that we can do in the field. And a lot of this does come down to intuition sometimes, but I think we're also limited by the tools that we have and the ability to diagnose a problem and then do anything about it. If there were it was to be something to be found in imbalance, and where I find there's some real innovation, and what I'm interested in seeing in the years to, as we continue to learn more about this, is that we can make more targeted and better informed decisions to promote biology in the soil in a number of different means. So as a collaborative, as the industry becomes more aware and the access to both testing and then maybe not just products, because it came to your point, I thought that was really wise. You get leery of the lab selling you the fix. Who's that data? But I think there's a lot to be hopeful for.
So moving on to the next question. So how do cereal grains specifically contribute to improving soil health on your farms? And then vice versa, as you've had cereal grains or different sorts of cereal grains, have you seen improvements in soil health? So both using cereal grains as a tool and the results of having those cereal grains.
Sure. We brought if anybody was at the fair yesterday, we brought some sheaves of this year's harvest for demonstration, but we also brought a rather hurriedly last-minute picked bouquet of sorghum Sudan grass that I brought with me today. It's outside. But as an example of a grain that we're growing purely for the benefit of the soil, we don't harvest our sorghum or our milo or whatever you call it, but rather we choose this hybridized variety along with other species in the cover crop mix specifically for the purpose of biomass production. And we know that if we can cut or high mow the sorghum several times through the summer and through the warm season, that it will double, triple the root mass. So we're told. I mean, I have not personally been able to verify that with data, but it stands to reason. And as you see in the field, as the plant regrows, I know it to be true. So just as an example, sorghum Sudan is one that works for us.
You're being silent.
No, this is it. There we go. Thanks, man.
Well, let's see. I think, Erin, you mentioned that the fibrous root systems of the grain are excellent for holding soil in place. There's a lot of root mass, so there's, in an organic system, there should be a lot of biology around those roots. That's one benefit from grain. I grow some sorghum Sudan also, mostly to fight weeds, but also to put green material and biomass back into the soil. Another thing that grains do, when we harvest, we don't bale the straw. We put everything right back, chop it up and put it back. So I think that's putting back potassium and phosphorus into the soil, so we're not taking that out. I know we're taking some things out in the grain itself, but we are putting that back. It's a carbon source also. So that's another benefit. And because you can grow grains, winter grains and summer grains, you can keep your field covered along with cover crops for most of the year. Right now I have the 5 little fields that I deal with. I'm mowing, I'm going to moldboard plow, I'm going to cultivate, and then I'm going to put rye in all of those fields. in the spring.
All in the next week.
That's right, yes, and before it rains again. But I'm hoping to keep that green on the soil, and it is a form of grain, of course, the rye. And then in the spring, I'll either let it grow or I will turn it under again. Unfortunately, I'll have to plow again to plant oats, for instance. I think this year I will be doing that. So I see those benefits for grain.
Yeah, it's, again, for the producers in the room, we're in good company. Thank you for being here today, because I think we all appreciate, has anyone drilled their wheat already? Has anyone done already? God bless you. You must be like, easy. All right, well, I want to be like you. But no, there's a lot. It's a lot that we can do, and limited by, sometimes by the implements that we have, informing the decisions. You mentioned plowing, and certainly through tillage, we similarly use limited tillage practices and try to turn in as much biomass, preferably as green as possible, in our one major till event as part of our cycle. But there's a lot riding on that. There's a lot that could happen, and certainly with the weather, one heavy storm at the wrong time, with the wrong tire prints, can really make a problem. So thinking about how there's so many different sort of factors to consider. However, again, I think that using winter grain or spring planted grain to disrupt weed cycling, or using your tillage practices, whatever cultural practices there may be, to disrupt seed production of those weeds, and weed management just categorically is just such an important portion of this. And the use of grain, whether it's for harvest or whether it's a component of a diverse cover crop mix, is really quite important, because a cereal grain paired with a legume, a brassica, and then maybe another, an amaranth or something, sugar beet, or throw another clover in there. Now you got 6 ways, and you keep going. Add some more species in there. You're creating that diversity, as we say, above ground to promote the diversity below. And a cereal grain, along with perennial grasses, and just categorically, perennial grasses are a real issue. But when we try to fight nature, and when we try to battle this great war, we will lose every time. And I think it necessitates a respect of the soil, and maybe realizing that we have small windows of time and to work, and a sort of a diminished understanding of the real complexity of what's happening. So that arrogance needs to check it out the door, but we have a small window. And maybe we could talk later at some point about implements and sort of some more of the practices, but I don't know if that answers, or we've gone off track here a little bit.
That's great. Could you talk a little bit more about the cover cropping practices that you both use with your cereal grain rotation?
Okay, most of the cover cropping I do is planting red clover when I plant a grain, be it whenever I plant it, or frost seeding in early winter if I have a winter grain, like a winter wheat or a rye. So I put in the red clover because after I harvest, then I have a cover crop in the field. And my combine is really old, but I can harvest, I don't know, a couple feet above ground, so I usually don't cut the clover also. Of course, introduce that green material into the grain, but that lets it out there and it can just take off. So with my limited time and equipment and so forth, and also limited funds, because cover crops can cost money, and it really, I think if I can keep doing what I'm doing and possibly introduce some more diverse cover crops, I think I'm going to do okay. I'm hoping to be able to put in a diverse cover crop in a couple of my fields this spring so that I can do the mixtures that you're talking about. But right now, red clover, seeded either with or after grain is what I usually do.
You know, we similarly had success with red clover, medium red clover undersowed our winter grains. Until we started using a tiner or a tine harrow. We have an Einbach tine harrow that we use in the spring as a surface cultivation to disrupt weeds. And we just didn't find the way to spread the clover only to disrupt it in the spring, recognizing there probably would be some survivability there. But we, said for the last couple of years now, since trying to figure out how to run the Einbach, which is not the easiest thing in itself. But so for this reason, actually, we've missed our clover application. And so much of this is about success stories, but it's also about the sort of downstream impacts that one mistake or a series of mistakes can impact for years to come. And it really does raise a challenge, when we're thinking about the consequences of our actions. Similarly, in our summer cover crop rotation, again, we are not growing corn, for example. In our summer cover crop rotation, we rely heavily on cowpeas and either sorghum sudan or sun hemp as a long fibrous material, just putting biomass back in the soil. But what we found, especially in the last 4 years, and really being able to rewind and look at the arc of this over the last 20 years, is really interesting in the quality of the fields, the changes in the fields. And we developed a cultural practice of planting cowpeas ahead of our winter grain. So in the rotation, we'd do our summer legume, a cowpea, and it would be inoculated with the rhizobium bacteria so that it fixed nitrogen, and we thought we would turn that in as a green manure and be able to maybe reduce some of our inputs by offsetting with organic materials. And we still do that. However, in the last 5 years, we've noticed the increase in perennial grasses and warm season grasses in particular, very difficult to remove. And in a rotation where we're not using herbicide, the mechanical control of a grass mid-season, if you want to preserve your cover crop, is all but impossible. So going back to that point about fighting the battle, and maybe leaning into it, I think is really the path forward. As we think about innovative ways that we can actually put the land to use, and this system design that will change over time. So how we're farming today may look very different than how we're farming in 10 years' time. So again, it's just interesting to observe that there is differences, but even in our current cover crop rotation, it too may change over time based on the actual conditions of our fields.
Yeah, I think this is building off of the points you're making, but the next question I wanted to ask you was, since you started your farming operations, have there been any shifts in mindset related to soil health? Or if you went back to where you started, is there anything?
No, they still think we're crazy. The people driving by, oh, you mean us?
Yeah.
Oh, okay.
But is there anything that you've changed in terms of your thinking about management, or anything you would have, going back to when you started, you would have done differently, like seeing the results of your practices on soil health?
Yes, I think I would have done some things differently because I had never farmed before. I grew vegetables for many years, but I was never on a tractor. I guess it was 2011 was the first time. So I was learning as I was going. And the fields that I inherited had been herbicided heavily. It was corn and soybeans, and they're small fields, 2 acres, 1.7 acres, and so forth. So I don't have the volume of land to work with, but I didn't tend to the soil all year long. I let it fallow. I plowed it and let it fallow over the winter, and really didn't understand exactly what could happen if weeds really got a toehold. And then I thought maybe I'm plowing too much, so I didn't plow much at all and let some fields fallow with red clover and the weeds that came up. And that bit me in the foot also, because the clover can really make some really gorgeous Canadian thistle. It feeds it with nitrogen. So I failed there also. I'm learning with the PASA Soil Bench program, and with learning from you folks and just everything. I'm going to have to rethink what I do. So I have changed over the years, one direction and another.
And don't feel bad. I think we're all learning as we go, right? None of us is born with this. And short of the intergenerational knowledge that can be found, certainly, and then is out there, this is a brave new world. And you know, when we're discovering some of this and learning together, I think there's a lot of opportunity to maybe prevent some mistakes. Hopefully, this is something that, as we each learn from each other's successes and relative failures, we can avoid some of the mistakes. But sometimes it's just out of your control. You know, having a field perfectly ready for plant. I mean, and then 5 to 8 inches of rain for 5 days in a row. What you're going to do there is you're watching your soil wash away. So yeah, there's plenty of opportunity for second guessing, but inherently, I think this really pivots back to the idea of where possible. It occurs that we are people of hope. You know, that we have a hope to, the act of what we're doing is an act of hope. There's a chance to try and plant something now and hope that it works. So there's this idea that we'll continue. And I think that, again, even learning from our mistakes, finding the silver lining to it, sure, it might be as simple as don't make that mistake again, right? But in many cases, it's, you know, the problems that we find, that's where, you know, solving that problem unfolds the solution that we've been waiting for, you know? So it's difficult to see whether or not you do anything differently. But hopefully the mistakes we make aren't too expensive, you know, and that we can make the right mistakes. Hopefully not too often.
Before we open it up for questions from the audience, I just wanted to give you, David, if there was something you wanted to share about the equipment side of things, and the equipment you're using, and are there pieces of equipment that you think would be beneficial with maintaining and improving soil health? But just, yeah, curious to get your perspective on the equipment side.
Well, I mean, you mentioned that we are limited by the equipment that either we purchase or inherit, or somehow we have the option to use. And whether it's from a traditional plow or offset disc or some sort of you know, tillage equipment, whatever the tillage equipment that we're using in the field, you know, can dramatically change the texture of the soil, the depth, the friability, and really can cause some damage. We are now using a I-mounts spader, which is a 10-foot wide implement that goes through the field at 1.3 miles an hour. A lot of time to think about your life, but a lot of time to look at the soil. And as you're going through the field, you're not zipping across. You actually are going slow enough where you can look down and look at the decompositional structure. You know, there's some of the matter, the surface material. So this is huge. You know, and I spent, you know, I was in the tractor for 10 hours the other day. This is a short day. Over the course of a couple days, but we've got a lot of work to do. But this spader is really important because it takes what would usually be a disc using an offset disc on one direction and then altering my lines on a 45-degree angle and going disc in the opposite direction. And then with the resulting furrows, maybe I'll need a third disc around the border, only then to spread fertilizer and put down several tracks. Maybe I can do it all in one pass. Chances are I can't. If you need to spread lime to correct your pH, I mean, that's probably the most important thing you should start and look at is what your pH is. So correcting your pH imbalance, hopefully you did that before you spaded. And then again, a condition afterwards and then planting. It's a lot of time in the field. It's a lot of passes with your equipment, resulting in a lot of compaction. So again, yeah, it's some degree of envy that those boys down the road are in the field and they just zip in there with their 60-foot boom and and then they're out and then they're done and it's like, okay, but we're not playing the same game, and it isn't necessarily fair to say, in this case, apples to apples. In many cases, we're forced because, well, until prior to this community, and really prior to us having the ability to compare notes with fellow growers in this region, we really didn't have the ability to measure where was the benchmark. So we were stuck measuring against ourselves, which isn't a bad place to be. I mean, really, that's what we should be doing. But I think it's just the tools that we have certainly inform and limit some of the actions, but it can, like Gabe said earlier, I really liked his point. Let's do better. Let's not just take the easy route. Let's try to understand what we're doing, and let's do better to protect this soil.
So we'd love to get some questions from you all for the panelists, or if someone has a mic, if they could. If you need a mic.
Sure. I'm curious about microbrewing and what that means.
Microbe brewing.
Microbrewing.
Oh, I didn't realize the slide has been up this entire time.
Yeah.
Okay, that's great. There's, I think, Teena, do you do any foliar application on your farm?
Because of equipment, I don't have the equipment, which I'd like to have, yes.
And it is a challenge, but it opens up, I think, a whole nother approach to fertilizer application and biological delivery. So we have a 30-foot sprayer. It's an old Dumco unit, but it runs, and as long as you clean the screens and you tend the pump, it'll work. And the idea is that as we've, over the last couple of years, been spraying spring application of foliar fertilizer, we have been dabbling in sort of how do we efficiently create systems where we can brew and sort of create mixtures and recipes. And we, around this time, discovered, again, this sort of the idea of being able to take bacterial strains or certain fungal strains, but mostly in a bacterial solution, being able to aerate the solution, whether it's through micropore or air pump delivery, or if you have some cyclone, or there's a number of different products. But the idea is basically that in the years to come, we will be continuing to build out the infrastructure and experiment with more foliar application of spring biologicals that we brew on farm in IBC totes or various different buckets or systems of handling and pumping solutions. But there's a lot of research there that I think is also debatable. I mean, the idea of compost tea is something that I think maybe some people in the audience are familiar with, the idea of compost tea, as a delivery for some of those microbial communities. But if you don't have a microscope, and if you're not well versed with chemistry and the ability to identify by the species, how do you know what you're brewing? So starting with trusted populations, or if you have an inoculant with a known species list for your microbrewing, and you start with sterilized containers, well, to the best you can, you hope to try to make it sterile. So that's sort of what we hope to be doing more of in the future.
First of all, I want to thank you for being a resource on soil health, because I want to tell you that David and I had a meeting with our local soil Health Authority. And when we were talking to them about our planting program for the next couple of years, they said to us that it's unlikely that we could improve the organic matter in our soil beyond 1% because of the sun in Virginia would crisp or burn out our fields. Well, our fields, David, I was surprised to hear that response from authority. So we welcome your comments, but we also knew that he didn't understand.
Yeah.
But going back to your principles of the soil principles, we at our farm have 14 different fields in a neighborhood, but in terms of implementing a livestock component to our program, we would have to maybe do chickens.
Yeah.
And what happens when our neighbors have been putting chickens on their property? They're just part of the food chain because the hawks eat them. So it's unlimited. It's unlikely that we could do chickens, and we have. If we were doing livestock, we would need to fence each one of our fields. And some of our fields are 3 acres and some of them are 25 acres. So how would we work around getting the benefits of a livestock component into our soil program when we have such an unbalanced field crop population to deal with?
Yeah, no, that's a great question, because I definitely don't discount how challenging it is. I mean, not only from just a logistics standpoint, fencing and water, and then you have the market component to deal with, and then you can also, depending on where you are, different regulatory and nutrient management plan, food safety aspects of integrating livestock. So, is it a solution for every farm? There certainly are challenges. In the Midwest, I think we do have more infrastructure with our dairy farms and being able to do some partnerships with grazing. I'm also really hopeful, just generally, one of the things, and this kind of touches on some of David's comments too, and Teena's, I don't think, I get nervous about promoting technology too much because ultimately I think it's our connection with the land and the food that is going to keep us moving in a sustainable, regenerative direction, whatever term you want to use. But I do think that particularly if we can invest in scale equipment technology that is at a price that is not putting smaller new farmers at a disadvantage, there could be a lot of innovation that can help us with soil health, both with respect to integrating cover crops in the system, reducing tillage, but I think also with livestock, with some of the technology with virtual fencing and even some of the chicken houses that might be able to move across fields. So I still am hopeful and optimistic that can give us some answers to integrating livestock. I mean, I think some of what when we look at why integrating livestock is so valuable, and there's two things I hear from farmers that may or may not relate to the cereal grain rotation or relationships with other livestock operations. One is the perennial phase of the rotation. I think that goes into some of the weed challenges that we were hearing, and with any grain system, I think if it's heavy on one aspect, where cereal grains are definitely a cornerstone of a resilient rotation, I always say that we want to keep the weeds guessing. So changing when we're planting our crop, the row spacing, when we're harvesting, and that perennial phase of the rotation is just another tool for the weed management perspective. And I think that's part of why we have successful systems with animals, is because we have that perennial phase of alfalfa. So is there a way in our grain rotations, and maybe it's through more of a cover cropping, multi-year cover cropping phase. And I loved David's comments about with sorghum Sudan, and Teena's comments too about returning the straw. We just had a farmer. We have a farmer cohort that gets together every Thursday night, and they were talking, and I was asking them particularly about oat prices and why do you put oat in the rotation? And he said, I don't do it looking at the profitability or maximizing profitability over at that crop. I look at how it affects the overall ecological operation of the system. And I think we need to start, which again, I realize from obviously cash flow is important, but how do we put in perennials in the system, and how do we better account for the different services and what they're providing to us in terms of nitrogen, weed management, and So, what are the other functions of manure in of itself? I think when appropriately managed can stimulate soil biology, and we look at the ecological function of the system. That was obviously a natural part of the system, and so are there other ways to look at deriving those benefits? And I think what David's doing with composting is another way to well, we know that manure, part of that is stimulating the soil biology. Are there other ways that we can stimulate the soil biology? We need a lot more information on how to do that, I feel like. I know that I've been hearing a lot about the Johnson-Su composting method and trying to stimulate the soil biology that's kind of inherently thriving in the system. But I think it's, without integrating livestock, thinking about why does the integration of livestock help the system, and are there other ways that we can do that without having to bring animals on the farm? I think having those multi-year rotations of legumes and stimulating biology are key. So that's not really giving you a straight answer, but just some of the conceptual ways I think about it.
I think we've got a couple of questions here.
Hey, quick one. Both of you guys are doing cover crops on purpose, and in trying to fit in my farming with a regular day job, and like you guys have said, there's just never enough time. My cover cropping has sort of been benign neglect, so I'll pull the weed off, in early July, and then it seems as though there's weeds, fescue, summer, annual grasses that come up, all those things that are low enough when I harvest the grain that, I still get a decent grain crop, but I'm not, going back in and putting, or managing for a cover. I guess the question is that anything but sort of benign neglect, or is there any benefit to those weeds in there? And how much of a difference? I know I could be getting something better if I had clover and, had the real rotation, but is there any benefit of having that sort of dirtier system underneath, I guess, is the question.
So late February, early March, we're all looking at chickweed, right? Mouse ear chickweed. It's going to be out there. You're not going to get rid of it. It's going to be there. So once, or henbit, another dead nettle.
Galamsoga,
Right?
that's a little later, but yeah.
All the winter weeds that come on. This is just a poor man's cover crop, right? And it's growing there for a reason, right? It may not be a reason we understand, but it's growing there for a very specific reason. Those roots are doing something. They are holding the soil particulate matter together. And so, Chris, just to answer your question, when you're leaving the residue on the field, and maybe you're not immediately going in there and drilling something and we're turning that over, maybe there is, I think, processes and biological cycling of nutrient that continues to the end of the year, even if it isn't a clover or a specific crop. That being said, I think we all face the issue of looking at a field and asking ourselves, is this at its highest production? Can we get the most out of it? So I think it also becomes a question of what are the metrics we're using? What are we trying to accomplish, and how are we measuring that? And it may not just be in yield.
And if you do you mow after you harvest?
In a perfect world, actually, honestly, this year I came and mowed a week and a half ago before I tilled to plant the wheat, to try to get things kind of broken up some, but a lot of the time no.
Yeah, I think if you could possibly mow after you harvest, maybe not directly after, you're cutting the weeds down so that they don't set seed, or you're knocking them back. And maybe you have to mow a couple of times until you finally get to the field to do what you want for your next crop. Consider them a cover crop. And as long as you don't let them get out of hand, they are doing exactly what David said. They're there in the soil. They are a cover. So that would be one way to deal with them. I totally appreciate your lack of time. Totally.
I can just say from experience, I have a pretty large community garden. I just hit up different people, especially those who are into organic, natural food, and say, hey, I put a bunch of chickweed. Hey, the dandelions are coming in. They will come and wipe it clean. Don't be afraid to reach out to those folks, because they will take it and they will eat it. Okay? They will take their time to dig up individual dandelions to use the roots. So don't be afraid, they will come and get it.
Well, while I appreciate the sentiment,
It is not been sprayed.
I think we quickly run into scalability. And while, look, there's no substitute for hand pulling weeds, and they're certainly important. When we think about the intersection of community, though, this is, I think, the point that you were raising that is really valuable. And as we think about land use and land access to land, and the diverse ways that perhaps a farming system or a model that would work on our land that may not be something that we run. You know, the way for us to open up opportunity to leverage relationships within communities, finding people maybe who are specialists in poultry or mob grazing, and be able to build the relationships where we are able to use the land at its highest good, even if it may not be something that we're that works for us, or that maybe looks like somebody down the road.
So there's a lot of great discussion. It's a good time to promote, because we have to break for lunch, that we knew there would be a lot of great discussion and a lot of great knowledge in this room that we'd love to continue to keep getting together. So we are co-hosting, I think, OGRAIN and the Grain Alliance, these growing grains for soil health sessions. And it's going to be, again, more of this format where we're dialoguing, we're sharing information, asking questions. So we're hosting in January, February, and March along these different themes. There's paper sheets at the back of the room you can sign up. You can use your QR code. So I always hate to cut off discussion, but opportunities to continue this discussion into the winter, because this is just such an important topic, and there's just, it's so much fun to share the knowledge across our community. And we have to break, but I want to give our panelists time to just, is there anything else that you want to share as we wrap up the session?
Well, there was something that just happened this past week. I was talking to a large farmer in our area in Pennsylvania, and large meaning this guy grows about 1,000, 1,200, 1,400 acres. And he came to me really excited, and he said, I just heard that if you can actually promote soil biology, that you can get healthier crops, and that the pests and diseases won't hurt them as much. And he was talking about bricks, about the sugar level. This is a guy that sprays chemicals constantly, and somewhere he heard about this wonderful new thing of soil biology, and I had to keep from laughing. I mean, it was just so great to hear. So I think there is one person up in the Lehigh Valley in Pennsylvania that's going to change his ways, and I think that's wonderful.
David, last words on your side?
How do you squeeze a leaf of wheat to extract the necessary amount of juice to do a bricks test? I don't know how to do. I've been using a vice clamp. It doesn't work.
Use a Cuisinart spice and nut mill, and that will chop it up, and then you can squeeze it through a filter, wrap it in filter paper or milk filter, and squeeze it in your vice.
As always, Dan. Thank you. What a no, I mean, what a wonderful way to end and sort of like highlight the individual knowledge that is present in the room. And I hope that if there's a takeaway from either today or the continued conversation that happens in the winter months of next year, as we share knowledge about boron and silica deficiency, and maybe methods on doing something about it.
Well, thank you to our panelists, and thank you all for your participation.